The intent of this tutorial is to walk through the different spreadsheets and worksheets that are provided to past practitioners to design watering systems. First off, we're going to go through an example that shows how to use the livestock watering systems pressure system calculation worksheet provided to past practitioners by NRCS to design watering systems for past projects. So first off, we will start with an example here that may be familiar to those who went through the past watering systems trainings. This here example is combined acres. So what we have here is a scenario where we want to provide water to these fields down here that are being converted into pasture. And to do that, in this design, we pumped water up to a water tank via pressure flow, and then that gravity feeds down to the tree hydrant and portable trough at the intersection of those four pastures. In another video, I'll go through the spring development spreadsheet, but for now, we'll just stick with the pressure system. So as you can see here, I have called out these elevations of where the watering system components are installed. You know what, let's add a shutoff valve here. Try to make this a little bit more interesting when we're entering in our data. So first off, let's say Cambria. Okay, so you can go ahead and enter in your site-specific data for this watering system and water line. Depending on the funding source, of course, you may or may not need to put the farm and tract number on here. However, if not necessary, then you can feel free to add whatever site relevant information in there that you may need. For more complex designs where you've got multiple pressure lines running from here to there, you'll want to have multiple spreadsheets to check each line and each location. But for this one here, it's relatively straightforward. You remember from the design scenario, we had 25 beef cattle, 25 calves, and then the consumption per animal per day refer to the Penn State Extension livestock water requirements chart, about 5 for the calves. And then step 2 here calculates your total required water demand per day. All right, so now that we've selected our animal numbers and demand in gallons per day for the animal numbers, we move down to step 3, determining the target supply rate. This number is based on the number of planned drinking events per day, assuming each event is 2 hours long. Going to enter the number of drinking events per day that we're planning for, 2 or 3. I typically go for 2. It's a little bit more of a conservative number. So we need at minimum the 2.08 gallons per minute to supply water for 25 cows and calves. However, this would be what we would select for a scenario where we're drilling a new well. In this case, we have an existing well, so we are actually going to design based off of the source flow rate, which the farmer has told us is 5 gallons a minute. This value may be from a spring well, which is our case, or known pump flow rate for a planned or existing pump. So we are using rate from source. And then for our distance to the farthest watering point, we are watering all the way down to here. However, that is a gravity line. So for this spreadsheet, all we need to do is size the pipeline from our source at the existing pressure tank and up to the water tank at the top of the hill. So I will go in here, use this measuring tool. We are 421 feet from the pressure tank up to the water tank. And then the elevation difference. Now for this, our pressure tank elevation here is 1665. However, that water line is going to go down below frost depth and out under the existing ground below frost depth up into the pressure tank. So we're going to adjust these elevations just a little bit to get our true proposed elevations on the pipeline. So let's say our frost depth is 3 feet in this location. We will take 1665 minus 3. So we've got 1662. And then, as you can see here, that's about ground elevation is 1700. So we will take 1700 minus 3 for where the pipe enters the tank. And we have 1697 minus 1662, 35. So that is going to be our vertical elevation difference from the pressure tank to the highest watering point. 35 feet we're pumping uphill. Now that we've determined the vertical elevation difference from the pressure tank to the highest watering point, we're going to select the type of pipe. Few options there: plastic, steel, copper. Most likely going to be plastic due to cost of steel and copper. Then we'll try for a 1-inch diameter pipe, and then move along to adding in our fittings, which will help calculate our total friction loss in the system while also factoring in the length of the pipe, size of the pipe, pipe material, and elevation change. So to start, as here we are connecting to an existing pressure line. So to do that, we are going to connect to the existing pressure line with a T-fitting. And then let's say we have to bend around concrete in or around this barn. So we'll add in 2 90-degree elbows, and then landowner wants to add a shutoff valve at the beginning of the pipe. So we'll punch in 1, Go through this drop down and select gate or ball valve. There's also an option for swing check valve. And then at the pipe penetration at the proposed tank, we're going to add one insert coupling. May not be necessary. They may be able to just run the pipe straight through the wall of the storage tank. Not really need a fitting, but I tend to go more conservative when entering in these pipe fittings. So right now, looks like we are good. Spreadsheets telling us that the chosen pipe diameter of 1 inch results in minimal friction loss. Here we have the calculation. Total added length due to the fittings that we've entered, 27 feet. So total length in this system, when we're looking at the friction loss, is 448 feet. And then step D here, using the selected pipe diameter, selected flow rate, and friction loss equations, we determine that friction loss per 100 feet is 1.7 feet. Our total calculated length divided by 100 feet times this 1.7 feet equals 7.8. So the total friction loss for the scenario detailed above is 7.8 feet, which is equivalent to a loss of 3.4 psi. Then we will hop over to the second tab of this spreadsheet. Step 8 there, expected or needed pressure at most remote watering point, which may vary depending on the type of float. However, in this case, well, let's say we do have a float. We're going to leave that hydrant open, run it into a hose with a float and portable trough down there. So it says use manufacturer's recommended minimum pressure or 10 psi, whichever is greater. Most of those float valves can go down pretty low. Some can work off of essentially no pressure. However, for this case, I'm going to go ahead and just punch in 10 psi because we don't know exactly what float valve the farmer or contractor is going to use here. But 10 psi is a good general value to use. So the operating pressure at the pressure tank, we have 35, our elevation difference, divided by 2.31, that's 2.31 feet per psi, gives us 15.2 psi. And then our friction loss from step 7, we had 3.4 psi. And then our pressure needed at the outlet is 10. So total operating pressure at the pressure tank, we have 28.6 psi. So you round that to the nearest multiple of 10, which is 30. This is the lower setting of the pressure switch. A minimum setting of 20 will be used. When we add 20 to the lower setting, the higher setting is therefore 50. Use a pressure switch setting of 30-50. Make sure a setting of 20-40 has been calculated. So let's check that 20-40. Also does not result in any error messages. We're still good. However, we are going to stick with 30-50 on the pressure tanks. So steps 10 and 11, more relevant for if we're drilling a new well. However, in this scenario, we are not drilling a new well. We're connecting to an existing source, pumping the water uphill into a water tank. However, if we were drilling a new well, this information would need to be provided to the contractor, plumber, well driller, really everyone involved in installing this watering system, so that they know that they can correctly, accurately size the pump and pressure tank. So there you have it. That is a quick run through example of the PASS 007 livestock watering systems pressure system calculation worksheet. Useful tool if we are exceeding any inputs on the simple pressure system worksheet. And if you'd like to use a smaller diameter pipe than 1.25 inches, that's the simple pressure system spreadsheet is designed to be used for.